Again, welcome everyone, and thanks a lot for giving us the opportunity, EV Entrepreneur EV Show, to have this session. So the theme of the discussion is to focus on revolutionizing the electric vehicle experience, advancing EV technology, autonomous driving, and user-centric design. I would start with the introductions. We have Mr. Ivy Rao, Distinguished Fellow, Terry. We have Mr. Vaibhav Samre, VP Product, Battery Smart. Then we have Mr. Bhanu Prakash P, Head of Product Lines, Autonomous Mobility BA, Continental Auto. And then we have Mr. Nikhil Anand Khurana, MD and CEO of Fox Motors. Now, starting with the discussion, I would like to start with Mr. Bhanu Prakash first. Given that the background, looking at advanced EV software, telematics, and connectivity solutions, what is the status of autonomous driving in India? And how do you see this transformation of the technology? And how mainstream will this be considered? And what is the likelihood of it being available in the mass market vehicles?
Hello. Thanks, Prajat, for this question. I'll start a bit differently, like about the autonomous driving. So I would like to draw a parallel with respect to the smartphone evolution that happened in India. Yeah. So if you see a decade ago, no one expected that a smartphone will be revolutionizing in India, and it is going to be one of the big mass market in the world. Yeah, the way things have transformed with respect to the smartphone is the same thing that is happening even in autonomous mobility, or to start with ADAS. Yeah. So in smartphone industry, if you see, it has set a real good precedence that India is always ready for adopting the new technologies. Yeah. And at the same time, it can scale. We transformed from normal Nokia phones to a smartphone, and with respect to the ecosystem also really helped with respect to the connectivity by providing 5G, 6G, and also the digital services, digital payments, and things like that has really picked up. Yeah. So I see similar transition that is happening in autonomous mobility. For autonomous mobility, probably you need to little bit understand on what exactly or which level we are talking about here. Autonomous mobility starts with like you have 5 different levels, starting from L1 to L5, and so wherein L0 doesn't have any kind of automation. These are the levels of automation basically, and then you have level 1 automation and level 2, where you have lateral and longitudinal controls that happen. But the biggest challenge for the industry right now is transitioning to L3. Yeah, from L2 to L3. This is where the big challenge is, wherein in L3 the OEM has to own it. The complete onus of the vehicle's safety is on the OEM. Yeah, because anytime when you are giving or giving autonomy at that level, at L3 level, it is expected that the vehicle can take over when the driver is not attentive, or when he is not taking back the control. Yeah, and L4 and L5 is much complex and also expensive basically. So L4 is where you have hands off and eyes off. Yeah. So you can sit, and then the vehicle takes complete control of the vehicle. So these are the way that is going on. Though the technology, if you see, it looks futuristic. Yeah. So that is what we are aiming for. It's a kind of a moonshot. But eventually, what we are benefiting is the safety. Safety of the people. Even in India, if you see, the adoption has significantly increased with respect to the basic, L1 and L2 in at least mid and premium segment vehicles. You already see, ADAS being adopted. Yeah, so like ACCs, EBA means ACC is adaptive cruise control, EBA is emergency brake assist, and you also have lane keep assist and things like that. So these are basic safety mechanisms that are in place, and people are realizing the importance of these safety features in the vehicles. So that's where is slowly gaining the traction with respect to the adoption. And L3 and L4 is something which I would see, it might, have be with the premium segments, and also to a particular sector of the automotive, like like trucking, or else a robo taxi. But these all come with a bit of constraints, that you need to have a better infrastructure. You need to have a support with respect to the navigation systems like the GPS. The GPS also has to be highly accurate in order to localize yourself, and the HD maps that we talk about, basically to get the updated maps on a regular basis. So these are the extra dependencies that are always there in order to reach from L3 to L4. So this is how we are going, but I see a good amount of adoption already with respect to the level 2 autonomy, I would say, and then to the mass market as the regulation kicks in. Definitely this mass market wherein the lower segment, or where the volume is, also will have the basic features of 1V and 1R, what we call. So basically one camera and one radar. These are some things which can quickly give basic benefits like cruise control or emergency brake assist to save the vulnerable road users and yourself as a vehicle driver. So this is how I see Prajot.
So just a follow up to that, a very interesting point. You already have some of it already adopted in a lot of vehicles, but how you already must be facing a lot of current challenges, of course, part of that. How do you see that in the current scenario, and what are the future challenges that you're likely to achieve? Because you said the transition from level 1 to level 2, level 3, and then when you go to level 4, how do you see all of this put together, the current challenges versus how that can improve in future?
So again, here, the technology plays a key role. As if you see, it's a kind of, we are at a tipping point where all the technologies have come together within the autonomous mobility area. So like I would say, AI algorithms, so they have come into vogue. So traditionally we used to use computer vision algorithms, which has some limitation. So it was not scalable. Whereas in AI algorithms, there is a lot of dependency on the data. So it's data in and data out. So what you feed in. So for autonomous mobility to work effectively, taking care of all the edge cases. So this is one of the challenge what we feel. How much ever you solve the problems of detecting a vehicle and then braking, or detecting a pedestrian and then braking, but there is always an edge case where you might fail. Like for example, in India, you see a vehicle carrying a huge luggage, but then you are not able to see the vehicle itself, but then luggage is floating or moving around. So these are some of the challenges. Or a cow that comes in, and a different animal that comes in. So these are the edge cases. So for all these things, you need data so that you train the algorithm so that it can adapt and learn how to behave on the vehicle. So this is one of the biggest challenge. And for all these things, there is something called edge cases, or the compute that is what is needed for all these algorithms to work. So this is where, again, if you see the GPUs which are really getting used in advancing the technologies of compute, like NVIDIA is there. So we have complex compute that is again getting handy. So earlier we always used to have the constraint that my processor is just this much compute capability of, let's say 50 MIPS or 100 MIPS, but then you have currently you have teraflops and things like that. So this is what we are talking about. So this really helps in handling such kind of questions and the edge cases, and then moving to the next levels of autonomy. So these are some of the challenges, and at the same time opportunities also for the engineers to solve these kind of problems. So
do you want to give a perspective on this, sir?
The ADAS different stages basically are to assist driver and ultimately replace the driver to end with autonomous driving. I fully agree with what he said, but I am still not able to digest how any computer logic would predict most unpredictable behavior of a road user currently in India. We don't have any discipline of driving. I mean, I'm talking about the majority of the drivers. They neither follow the minimum distance, maintain minimum distance with the other vehicles on the road, or we have any discipline for lane changing. And with all these indisciplined driving habits, what majority of drivers have in India, added to that, we have different types of segments of vehicle plying on the even highways. And also added to that, as he mentioned, we have cattle also as an additional feature on the roads. With all these things factored in, it would be a real challenge for whoever is developing the logic for the that system to predict what a vehicle should do when it encounters this type of things. And this issue of automotive driving was discussed many times in the same year council meetings, and that time it was felt that we should not target for the total autonomous driving. However, all the features of ADAS which would help the driver to avert a accident could be implemented at their latest. So still notification has not come, but I'm sure various phases of ADAS systems which would help the driver are going to be introduced. And also other angle to total autonomous driving would be that in the auto industry, the employment created for driving the vehicles is a very high percentage of total employment from auto industry. So in India, with so much unemployment, should we move to autonomous driving at all is a question. Maybe for particular segment users like luxury vehicles, etc., yes, it may be good, but majority of the vehicles where the driver is a earning member and it is required for his earning. So whether it's good to replace the manual driver with a software-assisted ADAS system to achieve the autonomous driving is a question which we all need to debate.
Yeah, exactly. Thanks for your insights, and thanks a lot, Mr. Bhanu Prakash, for your insights. Now, as we move on, we spoke about autonomous. Now, if we move on to the EV design and user experience, we'll go to Mr. Nikhil Ankurana. Now, given that the background in which you are in retrofitment, we had a good chat before lunch on how it is happening. But I would like to ask you, how big a role would EV design and user experience play to optimize the functionality, aesthetics, and consumer engagement when it comes to retrofitment of electric vehicles? And followed by that, the most probably the biggest question is how are you coping up with regulations? So what are your expectations from the government body, and how are you coping up with that? I think that would be very good to know from you.
First of all, thank you for having me here, and I'm very delighted to sit along with Mr. Rao, Bhanuji, Vaibhav today. I mean, how Bhanu Prakashji explained what the ADAS performance, how the ADAS adaptation to our regular Indian driving conditions, and Mr. Rao played a great role of a contrarian here, I guess. And so when we talk about EV design and related to customer experience, consumer experience, it's always around three factors what I've understood from my past experience of 10-15 years into design, development, engineering. And I remember back in my school days or college days, inventing an all-new hybrid electric powertrain platform. At the age of 15, I filed my patent at the age of 17, 18 during my first year of my college. And even in that time, my focus was always upon how the powertrain could be evolved into an incremental power efficiency, and the performance could be derived from the existing powertrain, and it could lead to a consumer experience where they don't feel any lag, even if the performance, even if the efficiency, even if the drivability, even with the comfort of having an retrofitment, having an electric drivetrain integrating into the existing ICE-based powertrain was my thought about how I could deliver recuperative platform. So if I tell about my first patent was around twin recharging, recuperating platform where you could recover 50 to 70% mechanical losses happen in your manual transmission when you press clutch, change the gears from from neutral to first, then coming back to neutral, then to come second, and say like in a Formula One car, the time is around 0.3 or 0.4 milliseconds to change the gears, right? And our regular driving condition, when we talk about manual transmission, it's somewhere around 2 to 5 seconds, and our clutch is always pressed, right? And that was the idea in the first place. How could I recuperate all those losses while coasting? See, regenerative braking, we all know. We all are techies, I believe, here. And so regenerative charging was very easy to understand about the coasting. But when it comes to manual transmission losses from neutral to first, then coming back to neutral, then to second, and henceforth, in your typical Indian driving condition, our clutch is always pressed when we say, where is the momentum is getting lost? Let's recuperate that. And now adding to that performance durability, how could I recharge that battery bank and get it into an electric drivetrain? See, EV design is what my thought was, how I could integrate all the configurations. Talk about series hybrid, parallel hybrid, plug-in hybrid, and BEV configuration, so that it could never come as a debate whether we should have all hybrids or all electrics. Retrofitment should always enable the customer to adapt electric drivetrain performance so that it could enhance his experience, right? Talking about much more about the efficiency results, we got an incremental 40 to 60% increase in mileage, 30 to 50% decrease in your running cost. Like, believe it, right now what we are having in a petrol vehicles, what, 10 rupee a kilometer, and at that point in time, okay, the fuel prices were way lower than what I would believe for now, but a 5-7 rupee a kilometer, I really want to drive a 1 rupee per kilometer or a 2 rupee kilometer when it comes to CNG, and now if we talk about CNG as well, it's again at somewhere around 6 or 7 rupees a kilometer. So for us here to understand in the EV ecosystem, how our EV design when it comes to integrating from us, even when we talk about a stock BEV, right? Are we really calculating the performance of a battery energy capacity? Does the powertrain is taking all the juice up all into the initiation and the torque deliveries? Are we understanding the speed and torque curves when we design a powertrain? And when we do for retrofitment, it's always from scratch we need to develop for every model specific solutions. So like telling you about, we have 5 models right now, right? All are Maruti brand models, right? Swift, Desire, Baleno, Ertiga, Brezza. Okay, so for all these models, again it's powertrain and platform sharing as well, but we need to adapt the retrofit control unit in such a way that it could deliver really that performance of driving a Formula 1 car as well, or just not to benchmark it to the regular ICE powertrain, and we want to give the customer the experience of having that much more better experience. I mean, if a 0 to 60 in a typical Swift car, right? I'll tell you about it's like 0. It's somewhere around 8 to 10 seconds, right? But I wanted to give it in at least 0 to 16, 5 seconds or max 7 seconds, and it depends on curve weight, laden weight, and we all know how Indians put all the laden weight to add up to GVW and whatnot. But EV design tells you about enabling the vehicle to get that juice in a much more efficient way. Our ICE powertrains are what, 20 to 30% efficiency, and what the electric drivetrain could deliver you 70 to 80% efficiency if we really talk about the electrical efficiency of the vehicle as well. And the unique feature what we had in a retrofit, it's about driving an automatic within your manual, so your neutral becomes an electric. So adding up a feature of, think about 40 to 60% increase in mileage, 30-50% decrease in running cost, driving from 50 to 100% driving with zero emissions, and converting your automatic. Okay, when we drive an automatic vehicle, we miss the manual, right? Because we all are driving enthusiasts, I guess. And when we are having a manual, we say, oh, we always need to put up the clutch and change gears 1/4, right? So that's the feature of having a XEV solution. And when I say XEV, it's having all the configurations.
Right.
And that was the innovation what we brought in. And now when we see other OEMs are catching up, no, okay, when it comes to pure EV, BEVs, it's again a challenge. I mean, what are OEMs claims about 300 to 400 kilometer the range, and what we actually got here, 200, 150. And when we tell you about all our, see, every EV has its own design and form factors when it comes to batteries as well. Why not, Baba? You will agree to it, I guess. But so every application when it comes to from two-wheeler, from a three-wheeler, from a four-wheeler, from a PHEV, from a series of parallel HEV, or I say BEV into buses and trucks and whatnot. Every vehicle needs its own defined form factors, need to have that energy density to deliver the performance. And that's what our focus is. And I'm sorry if I'm taking too much time, but what was the question around government?
The government, like,
Oh my man, I am just not so happy around what government want. I mean, when government wants us to invest into R&D, into technology, into supply chain, again building a brand distribution, again giving in financial services solutions for the wholesale dealers and retail customers, is the government really wants to promote the EV ecosystem in a more conclusive and homogeneous way, or they only want to get the OEMs to invest in the market, in Indian market, bringing in FDI or one another manufacturing capacity? Again, that's help for job creation, that's help for the economy boost. But right now, what India lacks is a domestic EV systems and components manufacturing. We don't have localization. We don't have 50% domestic value addition to comply for the PLI schemes under what government has lodged up. Right now, my focus is only to make the government understand when it comes to retrofit something which is not factory fit. So we need to have exclusive HSN codes, exclusive GST frameworks for aftermarket EV systems and components. I've been telling you about on the GST. If an EV is sold at 5% GST on the batteries, when it comes to at the spares, it happens to bring 18% GST. When I tell you about a powertrain gear, every vehicle uses one gear or not. When it goes into cars, it goes 28%, right? When it goes to two-wheelers, it gets 18%. When it goes into a tractor, it goes 12%. When it gets into an implement of a tractor, it goes again from 12 to 18%. So right now, if I'm again making a retrofit for the end customer, sourcing the battery at 18% GST and then selling it to the customer at 28% GST, would it really make sense for my balance sheet and books from the suppliers? And how would I consumer adopt? Again, it would, at the end, it would be difficult for the customer to understand what the value he or she could derive from a EV vehicle. I mean, from an EV solution when he or she compares with an ICE vehicle. So are we really solving those challenges or not? Because that's the comparison and the reference to it.
No, I just want to add to what he said in terms of the issues what retrofitters are facing in the market. There are a lot of startups who have developed retrofitment kits for two-wheelers, three-wheelers, and also passenger cars. The major problem they have is with reference to the ARI certification, because whatever kit they develop, they need to get it certified for every model where they are going to use it. There's a big issue in terms of cash flow. Second problem is after retrofitment, when they go for correction of the registration papers, there is no instruction from MORTH to all the RTOs to do that, because we all know the central government has not really come out with any clear policy about retrofitment, and they said that they are allowing state governments to do this, allow this, but at the same time they have not done anything. So definitely some intervention is required from especially Ministry of Road Transport to instruct all the RTOs to upgrade the registration papers based on the conversion what has been done, based on the certified kits what are used. This is one of the major issues, because there are some retrofitters who are already doing retrofitment like Pune and Hyderabad, but they are not able to get the papers corrected. Some RTOs are doing without, because of their ignorance, and RTOs who are very clear about details, they are asking for MORTH instruction for doing the same. This needs to be resolved if retrofitment has to happen in big scale.
Well, Mr. Rao, the problem does not end at RTO or the Minister of Road Transport. It has got a whole lot of challenges when it comes to Minister of Finance, Minister of Heavy Industries. I mean, if I tell you more about it, I will just start crying here.
No, anyway, thanks a lot for your insights. That was very insightful. Now, if we move on, like you said, it just doesn't end there. Then we move to the battery side of things. And when we ask Vaibhav about, what is your opinion? Now we look at the current adoption of battery types, mainly LFP batteries is what we see. How do you foresee the future? We have had a lot of discussion on sodium ion and alternate chemistries. So what, in your opinion, is the next move? And followed by that, if that is implemented, how does it impact, or what is your opinion along with that on battery swapping as well? So these two things put together, maybe your inputs on that.
First of all, thanks for having me here, Pravjot. In terms of batteries, I think right now there are two prevalent chemistries. One is nickel, magnesium, cobalt, and one is lithium ferrophosphate, or LFP as we call it. I think NMC has an advantage that it is higher in energy density, and therefore it fits well into spaces where volume is a constraint. Let's say a two-wheeler, right? So most of the two-wheelers probably still use NMC. LFP, I think, offers greater advantages in terms of that it does not overheat. It gives you a much longer lifespan, right? In typically, in Battery Smart also we have seen that the average lifetime of LFP batteries is much greater, right? And I think there are many other technologies that are coming up. Sodium ion, it's not typically that energy dense, but so it will be used probably for energy storage rather than battery swapping and everything else. And then we have lithium manganese ferrophosphate that is coming up, which combines the advantages of LFP and NMC, offering a greater energy density. But I think these are upcoming technologies, and lot needs to be seen as to where they will find their application. I think the innovation in batteries, if it has to happen, I think in India for particular, has to happen in cells first, because a lot of, or I would say almost all of the companies in India are assemblers now. None of them are manufacturers, and people have been trying, and government is also pushing it. If you look at China, they are at prismatic cells, even in LFP batteries, and the technology is gated. So they, for example, China always exports a technology that is 4 years prior to what they are already using, right? So I think even in the current domain of LFP batteries, there is a lot to be done, especially in terms of cells. We are, you will see cylindrical cells or hexagonal cells. I think China is already on prismatic cells, so a lot needs to be done there. In context of battery swapping, as Nikhil also mentioned, I think it's like a category, right? And Endofast and Battery Smart together have created this category in India. Now Movin has also joined it, and earlier we started. I think when we started with NMC batteries, and we used to custom manufacture it. We had a 40 amp hour cell. There was a BMS IoT all custom made for us, Now we have gradually shifted to LFP batteries, and I think now more than 40% of our fleet is on LFP batteries, and we are seeing a lot of tangible advantages, of them. Uh, One major advantage is increased range. So with NMCs, typically we get somewhere around 40 to 50 kilometers per two batteries for e-rickshaws. LFPs can go somewhere around 70 to 80 very easily if driven properly. Right. So I think battery swapping would probably be the first industry to adopt the innovation if it fits the price range. And we are also kind of looking forward to the new cell technology coming inside India.
Okay, thanks a lot for summarizing that. Since we have limited down, I would like to go to Mr. Ivy Rao. Now, exploring the opportunities for collaboration and investment in research and development to accelerate advancements in EV. How do you see the strategic alliances coming across? You already mentioned that there's very little, probably someone pointed that out, the coordination between academic research and OEM. So, probably if you could throw some more light on that and look at how partnerships are coming up, it will be great.
If you typically look at the basic Indian situation, there's not much connect between the academia and industry. I mean, it was so when I was a student in engineering college. Same thing is said even today. What the industry does, wants, and what academia does, each don't respect others. As